I'm very excited for the session. I think it's a very interesting topic, and I'm excited for all our presenters. I really hope you have a nice time presenting your work. So this session starts now at 10. It's starting a bit late, and it ends at 20 to 12. Each speaker has 20 minutes. I'll show you your 5-minute limit, then you're at 15 minutes, and you can start slowing down. Then we can have some questions and answers. If the speaker runs over his or her 20-minute allocation, there won't be time for questions, but you're welcome to approach them after the session and engage with them. I think they'll enjoy that. Okay, so one reminder is to tag the CSIR ERS 2022 hashtag on social media when you post anything. And yes, so I'll be presenting the first speaker is Mr. Londiwe Motibani, and he will be presenting on the effects of high heat input on the mechanical properties of titanium alloy components produced by selective laser melting. Londiwe, you're welcome to present. Miss, I'm so sorry. My notes were wrong, but enjoy your presentation.
All right, thank you very much.
This is forward. Move one slide. So
Okay.
this is back.
The
Make a
pointer.
pointer.
Okay.
Sure.
Good morning, everyone. I'm Londiwe, as have been introduced, and indeed, I'll be presenting this work to you. Just a brief overview of the contents. We'll look at what is additive manufacturing, how does the South African additive manufacturing landscape look like. We'll look at different types of additive manufacturing. Then we'll really get into the work that was done in this project with the aim methods and the results that were obtained. I'll conclude and give a vote of thanks. So what is additive manufacturing? It is well known as 3D printing, but what is it really? So ISO and ASTM, which are international standards and testing bodies, define it as the process of joining materials to make objects from three-dimensional model data. This is usually done on a layer upon layer process, and this is opposed to subtractive manufacturing methodologies. Essentially, with subtractive methods, if you look on my left schematic, you'd start off with a block of material and you cut away until you get your desired shape or object. With additive manufacturing, though, you start off with a material, whether it's powder or wire, and with that material, then you build your object or your component just layer by layer. So what would happen is that you'd start off with your CAD model, what we call a CAD model of your desired component, and with this CAD model, then it's input into your machine software, and this machine software slices this 3D model of yours into layers, and these are the layers that the machine then prints, and at the end you have your product. Now, looking at the additive manufacturing landscape in South Africa, we've made substantial growth in the last decade. Our capabilities have matured to machine fabrication, to the manufacturing of critical parts for the medical industry, aerospace, as well as automotive and mining industries. Now, on the schematic on the graph is a couple of role players that are part of the collaborative program in additive manufacturing, also known as CPAM. And CPAM is an initiative of the Department of Science and Innovation. These role players vary in the industries that they work in, from research entities like the CSIR to tertiary institutions, various tertiary institutions. We've got Aerosud, which is a private company in the aerospace field, as well as SMMEs, such as Metal Heart. When we look at additive manufacturing, really, the ASTM has categorized the different types of technologies into 7 categories. And the first 4 mainly use their raw material, whether it's polymers, plastics, wax, as well as sand. Then the last three mainly use metallic powders or metallic wires as their feedstock. And we'll be looking specifically to, it's the fifth one, powder bed fusion, which uses thermal energy to selectively fuse regions of a powder bed. Now with metal additive manufacturing, as I said, we'll look specifically into the powder bed fusion category, and even more specific to selective laser melting. This is the process that was used with this project or this work. And typically, the type of machine setup would include a build platform, a laser system that will emit your laser beam, as well as a powder deposition system. And how the process would work is that you deposit a layer of powder into your build platform, and this would be a certain layer thickness, and this is one of your process parameters, so it would be a set amount. And once this has been deposited, the laser would come along and selectively melt this layer of powder according to your CAD data. After this, then the build platform moves down, and it moves down a distance that's equivalent to your layer thickness. And so essentially then you would have an X amount of space left. Then again, your deposition system would come again and deposit a layer of metallic powder, and your laser would come again and selectively melt this new layer now and fuse it to the previous layer. And so the process goes on and on like that until you have your final product. Now, the advantage in this type of technology, when in comparison to your conventional methods, is firstly the complex geometries that you're able to manufacture or to make. And really, you can build almost anything with this type of technology. It also has relatively fast production times. There's also less waste. What we do is that you're able to reuse the powder that you would be using. The powder that was not melted, you're able to reuse again. So it's less waste and more friendly to the environment. So we look at two SLM, as we call it, selective laser melting machines, which were used in this particular project. The first one is one that's housed here at the CSIR, and it's called the AeroSwift. It's a locally produced or locally manufactured machine, so it was built from the ground up as it stands there. And this machine boasts a 5 kilowatt laser, which is a lot of power, as you can imagine. And with this, we're able to build faster than your commercial systems. Speaking to increased productivity, having a bearing then on the production of your cost. It also has a large build volume, and it's a 600 by 600 by 2,000 millimeters. So it's quite big. It's one of the largest in the world, in fact. And with this, we're able to make large parts or many small parts. And as I had mentioned before, the powder that is used, we reuse. We essentially just dry it and sieve it to the correct size, and we're able to use it again. Again, speaking to cost reduction. Then we'll look at Metal Heart. Metal Heart is a SMME in the south of Joburg, and they've got various capabilities within the additive manufacturing value chain. They've got commercial systems. They have a SLM 280, which is the bigger machine, and they use it for different types of materials, for research purposes, for industrial purposes. And then they also have a SLM 125, which is a smaller one, and that one is solely dedicated for the production of medical implants because you don't want any contamination there especially. They also have capabilities in machining and cutting, as well as wire cutting, and for heat treatments, which are post-process types of processes in the hot isostatic press. So the aim then of the project was to investigate the effects of increased heat input on the mechanical properties of titanium, 6 aluminium, 4 vanadium components produced by high-speed SLM and commercial SLM. And this was motivated by the need really to benchmark this locally manufactured prototype platform and benchmark it to the commercial systems available out there. And so titanium 6-4 components were manufactured using the Aeroswift platform as well as the SLM M280 machine, which is a commercial machine. These were made from a commercially produced powder. And the thing that we're looking at here is the heat input, and that's a ratio of your laser power to your laser scanning speed. What we found, with the Aeroswift machine, remember I had said it has this large laser power, and so its heat input is also quite big. It was a heat input of 400 joules per meter, while the commercial system, which uses a much smaller laser power, had a heat input of 150 joules per meter. Tensiles, fracture toughness, and fatigue crack growth rate specimens were built. For tensiles, the machining and testing was done according to the ASTM standard E8-16, and the tensiles were built in the vertical direction. For fracture toughness, the machining and the testing were done according to ASTM E399-17 and ASTM E647-15 for the fatigue crack growth rate specimen. Getting to the results, we'll first have a look at the microstructure. And the reason for that is that it's the produced microstructure that actually determines your mechanical properties. So on the left, we have the high heat input results, which is from the Aeroswift machine. And on the right, we have the low heat input, which is from the commercial system. What we found in common was that the microstructure produced by both machines was a martensitic one. It was characterized by alpha lats that were found within prior beta grains. The difference, though, was with the shape of the prior beta grains. For the high heat input, these prior beta grains had grown epitaxially, meaning growing vertically up. I see it's not very clear, but on there you can see the lines showing the long columnar grains. So those grains were long and growing in the upward position. With the low heat input one, though, we found that these prior beta grains had an irregular shape, and as you can see on that last slide, in that last picture, you can't quite see the long columnar grains. And this was attributed to the different scanning strategy that was used for each machine. Getting to the tensile results, we're looking at the ultimate tensile strength, which is the blue, the yield strength, which is the green, and the dark blue is the percentage elongation. When we compared the outputs of the two machines, we found that their ultimate tensile strength was more or less the same. It was in the range of about 1,200 MPa, as well as their yield strengths. They were also quite similar, 1,000 to 1,100 MPa. Their elongations, though, did differ, by not so much, but they were different. For the high heat input, the elongation was almost 5%, while for the low heat input, the elongation was almost 7%. And these results were quite interesting because if you look at your wrought material or your conventionally manufactured titanium, your UTS and yield strength are quite low, just above 930 or above 860, compared to the 1,200 and the 1,100 that we're getting here. But the elongation with the SLM processes was lower. And this, again, as I mentioned, that the microstructure determines your mechanical properties, it's a fact and a reason for the difference in that. The martensitic microstructure is known to give very high strengths, but low ductility, as in the low elongation that we see here. But of course, these are properties that can be tailored for client-specific needs. Then we look at the fracture toughness, and fracture toughness is essentially how a material absorbs impact. And here, the results show that the high heat input had a fracture toughness of about 43 MPa root M, while the low heat input was lower at about 36 MPa root M. The micrographs on the right show the actual fracture surface. We study that as well. And the bottom ones are the higher magnification micrographs, and they showed a characteristic dimple-like type of fracture, which shows us that the material was ductile. Both materials were ductile. And it was interesting to see the step-like type of fracture in the high heat input, and that is on there. Then the fatigue crack growth rate results. This is a Paris curve, and this shows us essentially how the material responds to crack initiation as well as crack propagation. So the important factors that we look at, or the values that we look at, is your delta KTH, which is your stress, it's your threshold stress amplitude. And with that, it gives, if you have a high delta KTH in value, it means that your material is able to resist crack initiation. So it's not easy for your material to start cracking. We also then look at the slope of the graph, the slope, which is your M value, and the slope of the graph indicates the rate at which your material, or the rate at which your crack propagates through your material. So of course you want it to propagate at a slower rate. All right, thank you. And so what do these results tell us? We see that the delta KTH is quite similar for both machines. What we do see though is that the slope for the high heat input has a lower M value, and so it's a shallower slope, meaning that this material from the high heat input machine has better crack propagation resistance. And so to just wrap up, we saw that both the SLM machines produced a martensitic microstructure that was characterized by alpha dash lots found within prior beta grains. The tensile results were comparable. We did note, though, that the low heat input specimen did display slightly better elongation. With the dynamic mechanical properties of fracture toughness and fatigue crack growth rate, the high heat input specimen showed better results. And so what we can say from here is that the effect of using high power, as in our locally produced prototype machine, does not negatively affect the quality and the mechanical integrity of produced parts. It produced parts that are quite comparable to your commercial systems that are out there. And with this, then, we say that the advantage that we have with this machine is not lost. We can build faster, and we can build just as good as the commercial systems out there. And so we invite you all entrepreneurs for future work with us. We can accommodate part production, material testing, as well as material validation. Finally, just to thank the group to thank the staff in the laser-enabled manufacturing group, with a special mention to Dr. Lerato Shabalala and Dr. Ndombi Mate, who were the supervisors for this master's work, as well as then Prof. Natson down at UCT, who was the main supervisor for this project, the work that we did with Metal Heart, and then the Department of Science and Innovation for the funding for this project. Thank you very much.
Thanks, Andiwe. I think we have some time for a few questions. Are there any from the floor? Yeah, I have a question. So you say your aerosol system can produce faster using a higher heat input.
Yes.
Can you also produce them more cost effective compared to other commercial SLA systems?
So the cost effectiveness will come in terms of the time that you save in production. So your production costs would be less because you're taking a shorter time to build. So it's actually the cost associated to the manufacturing process that would be less than your commercial systems. Yeah.
This is very interesting.
Thank you.
Any other questions? Yeah, there's a question at the back.
CAD is computer-aided design, and there's various commercial softwares that are out there. SolidWorks is one of the popular ones. We use Magix as well. Yeah.
Okay, thanks. Second question.
I just wanted to find out, you talk about reusing the powders. How many times can you reuse the powders for these processes?
That's a very interesting question, and studies are now coming up in terms of really looking into how many times can you use it. And so far, you can use it perpetually until more, because I think people might wonder in terms of, does the powder degrade or does it not? And so far it's found that the powder is actually quite okay. You might run into problems then if, for an instance, you didn't sieve properly and you've got agglomerates of the powder. So if all your reusing systems or processes are okay, you should be fine in terms of reusing it.
Thanks. Are there any last questions? Okay, at the back.
Hi, this is some really interesting research. I was wondering on the scalability of it. Do we only have one machine that can do these prints? And if we do, how hard would it be to recreate it?
So this was the first one in terms of the size and the scale, more especially in terms of the build volume, because 2 meters is quite big. What we have developed subsequently is smaller machines that use the high laser power, because that's one of the, or almost the main point is the high laser power, so you're able to build faster. Also, there's been a spin-off company that has come out of this capability of building machines. And so I think they've built 2 so far, and there should be more coming in the very near future.
Thanks. Thanks, everyone. Okay, if it's a quick one, you can quickly ask it.
So the unused powder, we don't have unused powder. Let me put it that way. All the powder we do use, and we reuse it. So the powder that's not melted to make the component, we sieve it, we dry it, we sieve it, and we reuse it. So there is no really discard per se. It would be in terms of the filters in the machine where there needs to be some powder discarding, and that is usually done in a safe manner in terms of a company that actually handles powder waste. But those are the very ultrafines that would be found in the filtering system of the machine. It's not quite the powder that we're building or building with.
Thanks, Londiwe. I think after the session, I also have a few interesting questions for you, and anyone else can also approach her after the session. Thanks. Let's give a hand to her presentation. Okay, the next speaker is Dr. David Swane. He'll be presenting on oxidation and corrosion mechanisms on a titanium alloy surface, the density functional theory. Thanks, Dr. David.
Just go this way. This is back, this is forward. Yeah. Sure. Then that's the point. Okay.
Thanks, Madam Chair, and greetings everyone. My name is David Swane. I'll be giving a talk titled Oxidation Corrosion Mechanism on Titanium 2 Aluminium 1 Vanadium 1 110 surface. This is a density functional theory technique. Maybe to put the house in order, I'll be using some of the words interchangeably. The oxidation I'll be used interchangeably with adsorption of oxygen. When corrosion, I'll use it with adsorption of chlorine. And density functional theory is a computational modeling and simulation, known as first principle or ab initio approach. The outline of my presentation is as follows. I will give you the background, the introduction of the study, structures and application. I will analyze the pure surfaces, it means before adsorption, and also analyze the adsorption surface, conclude and give some acknowledgements. Just to break the ice, you all know that titanium, aluminum, vanadium, or titanium alumini alloys have already got interest in many industries, starting from electronics towards the biomedical applications. This is due to the superior property observed on the titanium, aluminum, vanadium alloys, such as lower density and biocompetitiveness. However, as many other materials also suffer some defaults or have some disadvantage on the structure application. And one of those disadvantages is higher affinity to oxygen or any other halogens ions. So basically they react easily towards the atmospheric or the condition, of which at last it forms the oxidized layer on the surface. So it results in surface instability. So it means now the component will suffer surface mechanical stabilities due to this formation or due to the reactivity of the component with the oxygen. So it results in oxidation or the component become corroded. Therefore, in order to understand the level of microscale of this oxidation and corrosion of the component, we have to first analyze the manifestation of this oxygen. When does this oxidizing layer form, or when does this component become corroded? And of which we only find it when we do computer simulation and modeling based on ab initio. So we are studying the first stage of oxidation, where it will arise. What will be the contribution to that oxidation rate? Then we are on density functional theory, can give us the liberty or a suitable package to investigate the oxidation at that level. So in this case, we'll be focused on density functional theory, which is the first principle approach, using computer simulation models to investigate the material property. Now we will have our oxygen and our chlorine on our titanium 2 aluminum vanadium surface. We will treat these as impurities towards our surface. So when I mention impurities, it means I will either refer to oxygen ion or chlorine ion. Going furthermore, here I want to show the crystal structure of titanium 2 aluminum vanadium. Then we first determine the thermodynamic stability of the phase using the equation to calculate the heats of formation, using the equation over there. So the E total means the total equilibrium total energy of the crystal structure subtract the sum of an individual elements inside the crystal. And then you get the formation energy of your crystal. So we found that the magnitude lies around minus 0.12. So getting the negative magnitude shows that our structure or our phase is spontaneous. Therefore, we also analyzed the lattice parameter, and they were well comparable with what have already published in 2012. Then different colored sphere represent each and every element in the crystal. Over here, figure 2, I just wanted to show the application where the titanium alumini or titanium aluminum vanadium might be applicable, from the aerospace down there to the medical and industries. So to go further and break down the modeling in terms of scale or hierarchy, we start at the lowest scale, which is where we investigate the behavior of electrons or charges, and then we can be able to predict the material property. We learn how the electron and charge behave, and then we can predict the behavior of the material exposed to any other thing. So this is based on electronic and in the scale of angstrom, nanometers, and it's mostly applicable in the discipline of physics, chemistry also. The equation that plays an important role there is well known, the Schrodinger equation. You can at least go up a scale at an atomistic level, where now you study the behavior of atom interaction. And then you can also be able to predict the material property of your composition or your crystal structure. And it normally uses the first known Newton's first law. And then one can model from the electronic level, means you can determine how the charge electron behave. You go to atomistic, you go to micro, up until the micro level, which is a discipline where the engineering and material science at some points play a huge role there. So one can determine from here going up and from up going down. The genealogy or the principle will remain the same. You will observe similar properties, but it will be based on the level of the scale. So basically on this study now, we are on computational modeling. So we are on the scale of density functional theory. So this is a quantum mechanic approach used in physics, material science, to investigate the behavior of a material. So it lies more on Schrodinger equation. There are various software or soft code that can be used to determine or to model the structure. But in this study, we use Material Studio. This is a package, software, and then we used a custom code. And the parameters were set, cutoff energy and the K points. And there are more parameters or algorithm playing a big role on this simulation, but I just mentioned a few of those. However, if I have to go through the algorithm and everything, it's a story for another day. So if you are more interested in that, we can sit down and show the algorithm how it works. Now, on the results, we first check the pure surfaces. To be pure because we didn't even include any impurities. So from the crystal structure that I've shown, that is titanium 2 aluminum vanadium, we create a slab, or we create a surface where you have a stack of layers sitting around each other. And then the termination represents where now the top layer is exposed towards the environment. That is the termination in which your surface or your slab will be in. Then, because we are more interested to have all the elements at a termination, so we need all the elements be exposed. So we have chosen 1, 1, zero surfaces. However, also it was found to be more stable. And our results were well comparable with what I've listed on the reference over there. Now, maybe before we go there. Now, this is a side view of your slab. And then over here is a top view. Now we are looking at the top view. Then you can identify the reactive sites where the impurities, if the impurities is there, it will settle in and react with the surface. So we have few of them. So we have titanium, so it means now the impurity can sit on the titanium atom. The impurity can be on aluminum or can be on the vanadium. Also, we have a bridge where two atoms, either identical or non-identical atom, the impurity can sit around and interact, or that cause a bridge site. And then you have a certain where the atoms are situated in a certain shape, either in the hexagonal or in the FCC space. And then the impurities can sit in the hole, so it's named as the holocyte. So impurity can sit there and react or interact with all the atoms surrounding the reactive site. So when I mention the top side, it means it will be on the top of each and every atom. The bridge, it will be between the two atoms, and the holo, it will be on the holo side. So now, this is an optimized system or optimized structure after the impurities was introduced to the vacuum, and then it interact with our surface or our slab. And then you have the red sphere that represents an oxygen atom, now is on the bridge side between titanium and aluminum. And then we also have oxygen on the bridge side between titanium and titanium and so forth. But I just mentioned just the three of these. And then you have the holo there. Now the oxygen is sitting between all the four atoms that are on the top surface. So it means that it's a holocyte reactive. Then now, because we know already, our simulation shows that the impurity will sit on the top surface. Then now, how do we predict the interaction stability or the interaction strength? We do it by calculating what is known as absorption energy. So it's the interaction energy between the molecule and the surface, or the impurity and the surface. And the E sub/mol, it will be now the equilibrium final energy when the impurity is on the surface. And then we subtract it to the final energy of the slab, which is the surface, and final energy of the molecule, which is in this case, is our impurity. Therefore, we can measure the strength and the stability in which the impurity will sit and sleep even on the surface. So we measure that by checking the magnitude of the adsorption energy. And we found that looking at the magnitude of oxygen first is even larger than the magnitude of the chlorine. So it means checking the magnitude being negative similarly represent that the reaction is exothermic or spontaneous. Then we check the magnitude value. We found that on the oxygen side, we have a largest negative magnitude. So it means now the oxygen will react more easily, or it will be stable on the surface as compared to chlorine. So it means now our slab or our surface or our crystal structure will suffer more oxidation by oxygen than corroded by chlorine ion. Then we can predict that. And then let's check which side or which surface side was more reactive on this case. And then we see that the holocyte and the titanium vanadium bridge side, looking at the magnitude of the adsorption energy, it shows that the holocyte and the titanium vanadium bridge side are the most reactive side on these surfaces. Checking on the chlorine also, the holocyte was found to be more reactive, but now the titanium bridge side was found to also become more reactive towards the chlorine interaction. So it simply says the surface or the crystal will suffer oxidation than suffering from corroded by chlorine ion. Then we further continue on to analyze what's known as work function. Work function is defined as the minimum energy required to remove a charge or electron from the surface to the vacuum. I relate this to some of the sample experimentalists used to do. They go to the lab and they say they are polishing or they are etching. This is a kind of same technique. So now, we are measuring the work function. First, we measure the work function before the impurities was on the surface. And then we found that including the impurities on the surface in fact increase or induce the work function. So it means the impurity will form a dipole moment on the surface, and then it will be very difficult to remove it afterwards. So by checking at the magnitude f, which after impurities have increased the magnitude of the work function, and it's defined by those kind of figures over there. We continue and check the charge density distribution. Now, after the impurities have interacted with the surface, we check which side has been corroded or which side has been oxidized. And then we measure the charge density distribution within that. And the algorithm will use this kind of equation to determine the charge density distribution. And of which the colored region, the blue ones will refer to charge accumulation, and the yellow will reflect to charge depletion. So accumulation means charge has been deposited there, and the depletion, it means charge has been withdrawn from there. Then now, this is our oxygen on the bridge side, and this is our chlorine on the holocyte. You see now the yellow region is underneath, so it means now that side has been lost charges or has been corroded. And looking on the shape of which the oxygen, the shape of the charge density distribution, it shows the ionic bonding because it shows a spherical shape on the colored region. Then in conclusion, I will say we have finally utilized the density functional theory technique or approach to investigate the corrosion and the oxidation on titanium to aluminum vanadium successfully so. And then the result demonstrated that oxygen adsorption strength is more energetically stable to the surface other than the chlorine ion. This implies that if there is surface exposed to oxygen or chlorine ion, it will suffer more oxidation than a corrosion. And we also observed that the oxygen and chlorine also induce the surface work function. And I would like to acknowledge the following parties for their different contributions. There's CHPC for their computing resources, Materials BioVia Studio and Materials Project for database and also for interface, then DSI for funding, and the individual for Dr. Modiba and Govender for their contribution in this work. And I thank you for your attention.
Thanks for your presentation, David. That was very interesting. Are there any questions from the floor? Yes. Okay, you're in the front.
Thank you for the great presentation. So I have two quick questions and that need two quick answers. Your theoretical model. In your literature review, were there any other theory that existed or that identify? And what was the rationale for using the density functional theory as a theory that underpin your study? Secondly, as you see, the theme of the symposium is innovation in entrepreneurship. Can we commercialize this work? How can you commercialize this work? Thank you.
Oh, thanks very much. I will start by saying, in terms of the theory, density functional theory, I've done it from my master's, PhD. There are more work that we have published on the density functional theory approach, where we investigate so many materials properties, and then we found that they were very comparable, or in fact, they were very relevant to the experimental data that we have observed. So the approach, it has been there for quite some time, but it was not utilized at the level, at the highest level scale at which it can provide the solution to the material science and engineering problems. So I will say we are doing quite well, and then we are very, our data is very much comparable with what we observe outside. Based on the study itself, there are so many work observed on the ternary alloys that have investigated the lattice parameters, the behavior of the ternary alloy, how it observed, and the oxidation also. I have one correspondent on the titanium, aluminum, niobium, which it was my benchmark, looking at the magnitude at which the oxygen or the chlorine interact with the ternary alloy. As coming to commercializing that, I will say already is commercialized. The theory is within the CSIR, the software are within the CSIR, and we are utilizing the technique to solve the client's problem coming to material science and predict the composition and or the phases that observe on the material or crystal.
Thanks, David. I think that was well answered. I think we'll have time for one final question, and then the rest can ask their questions after the session. Thanks.
Right. Thank you, David, for that. Am I audible?
Yeah. Yes.
Thank you. Sorry. The issue on how have you managed to package this as far as like on this is not touching again on the commercialization aspect at TRL level as a technology demonstrator or package that you, and at what TRL level is that? Because you mentioned yes within the CSIR, but as far as rolling it out into industry, have you worked with any spin-off companies or potential SMMEs?
Oh, thanks very much. If not me per se that I've worked with the industry, but the group that I'm in already, we are doing the work to predict some of the composition based on the industry requirement and the level in which they want their composition or want to predict the phase that they need to observe on that. In terms of other things at some point, yes, all the package or the software and the technique is with a Center for High Performance and Computing, and I would say we are doing a great job in terms of working with outside people to solve their problem using this theoretical approach.
Okay, thank you very much, David. The other two questions and any other questions are welcome after the session. Thanks for your presentation.
He knows what to do.
Will you put it up? Thank you very much. The next speaker is Mr. Stefan Kamaransky. He was actually one of my vacation work students, so this wasn't his project, but I'm excited to hear his talk on this work. It's on developing a trajectory optimization physics engine. Enjoy.
Good morning, everybody. Firstly, I'd like to say thank you to Londiwe and David for your very informative presentations. I thoroughly enjoyed it. And as you all know, my name is Stefan Kamaransky, and I'll be presenting my topic, Developing a Trajectory Optimization Physics Engine. Okay, so this presentation will begin by introducing this research, as well as some background information and the problem. And then we will move on to the objectives of the research. Excuse me, I'm just having some technical difficulties. There we go. We'll move on to the objectives of the research, as well as the way the research was conducted. We'll then move on to some details on trajectory optimization, and then we will look at the dual model physics engine, a few practical use cases of this physics engine, and then we'll conclude the presentation and look at some future research that can be conducted. Okay, so robots, robots, robots. Robots offer immense value to society. They are used in many industries, developing mankind significantly. Legged robots are the future of robots. These robots are made up of multiple limbs, and you can see in the slide over there. They are extremely versatile, but they also come with extreme complexity. And we do not fully understand their movements just yet, especially the rapid movements. So robots are also very expensive, and we want to try and avoid all damages that we can to the robots. So it is critical to test the robots in a physics engine before deploying them. Okay, so current physics engines are not able to accurately model the impulsive nature of legged robots, and this is due to their implemented soft contact model. The soft contact model implements contacts by determining the penetration depth and velocity of the robots through the contact surface. A spring and damper system with user-defined gains is used to launch the robot off of the ground. So this animation does not serve to show the trajectory generated by the physics engine, but rather to illustrate the way in which the robot's foot penetrates the ground and hops up using the spring and damper in current physics engines. So the problem with this implementation is that it is very inaccurate for legged robots, which have large ground reaction forces. So small changes to the user-defined gains can cause large differences while working with these ground reaction forces. And if the robot is implemented physically, then this can lead to big inaccuracies that can cause serious problems and damages to the robots. Another limitation of current physics engines is that they cannot implement slip without a fixed contact model. So what this means is we do not want a fixed contact model because we do not want to enforce a contact order. So all of these problems result in a novel physics engine that is needed that can be used to test and develop legged robots and their controllers accurately and quickly. So we'll now move on to the objectives of this project. The objectives of this project include building a physics engine that should use a hybrid dynamic approach with a sliding window style format, which we'll get onto later. It should be able to model a monopod, which can hop up and down, simulate simple controllers, handle multiple contact events, and handle different contact surfaces. So moving on to the process. The physics engine is developed using two different models, a contact model as well as a non-contact model, and the robot is modeled as seen here. So the ground is also modeled as a flat surface with height z is equal to 0 meters. Okay, so getting into a little bit of trajectory optimization. Trajectory optimization is used to model the dynamics of the robot, their environment, and the interaction between these two. So the models are created using multiple constraints and bounded variables that the optimizer can vary. So the robot has 5 different degrees of freedom. This includes the X position, the Z position, and the body, thigh, and shin angles. So these are all things that the optimizer can vary. These are termed the generalized coordinates. And these generalized coordinates are used in many of the calculations required to calculate the equations of motion. So the ground reaction forces in the equations of motion are only applied to the contact model, because that's only where contacts are happening, right? So the equations of motion are one type of constraint used, but as you can see, there are many other types of constraints used. And one of these is nodes and collocation, which we can spend a whole nother presentation talking about. But each trajectory is discretized into n node points, right? So between every 2 consecutive node points, there are also 3 collocation points. And a constraint is added to ensure that the third collocation point of one node is the same as the same collocation point as the next node. So this is displayed in the figure, as you see over there, as the second node point. I'm not sure, my hand is not very steady, but this point over here is a node point, and these are all collocation points. And as you can see, this over here is constrained to be at the same point as the node points. So The time period between nodes was chosen to be fixed for the non-contact model, and this was possible since no syncing of the contacts and node points was required, seeing as there were no contacts. So on the contrary, the contact model makes use of a variable time step in between nodes, which the optimizer can vary and change the time step. This ensures that the contacts occur at node points and not between them. So the complementarity constraints are only applied to the contact model. These include friction, foot slipping, and ensuring that the ground reaction force is only applied when the foot is actually on the ground. Other constraints such as the motor model, terminal conditions, the cost function, and bounds are then also applied. So the optimizer uses gradient descent to optimize each of the variables. The starting point of the gradient descent is also known as the seed point, and this is generated randomly. This can assist with bad seeds, such as the red component in this animation over here. And if the optimizer cannot find a feasible solution, then we can just reseed randomly to mitigate this, and then you can see by the green components over here. Okay, so the complementarity constraints are extremely difficult to solve computationally, and consequently epsilon relaxation techniques are used, and this implies that the problem is solved multiple times over, each time reducing the tolerance, reducing epsilon, and thereby increasing the accuracy of the solution. So seeing as people seem to prefer visualizations, and this is a simulation, so I created a small animation for you guys to see what's actually happening. It's a very basic monopod robot, and this is the contact model, just to simulate a result to see that it actually works. We can see that the robot starts up in the air, it falls down, hits the ground, and exactly as predicted, we can see that the Z position of the foot drops down, hits the ground, and as it hits the ground, exactly what I was talking about before, a very impulsive, high ground reaction force. And then for the non-contact model, a similar test was done. Drop the robot from the air, fall down, and as expected, it does not hit the ground. It goes straight through the ground as expected. So we can see that the Z position of the foot goes straight through the ground. Okay, so moving on to the dual model physics engine. So the two models are now integrated into an overarching solve loop. And upon entry of this solve loop, the foot height is checked to determine whether the robot is in the air or if it's making contact. So in each of the contact and non-contact loops, the initial conditions are applied. As the seeds are generated, the model solved, and the trajectory then saved. So the contact model makes use of 10 nodes, and the non-contact model makes use of 300 nodes. So the non-contact model is very expensive computationally, and we would rather run multiple iterations of these 10 nodes than one iteration with a large number of nodes. The physics engine is implemented using a sliding window approach. So you can imagine that this is a window that is slid over time, and as you slide the window over time, each time that you slide it over, it is solving that short time period, and you just repeat this process. So to transition between the models, the values of all variables at the second last node points of the previous trajectory are saved as the initial conditions of the current trajectory. Since the non-contact model may complete its trajectory as penetrating the ground, as you saw in the previous slide, backtracking is implemented where the last valid node point, in other words, the last node where the foot was above the ground, is then saved. So the seeds for the contact loop are set by using the values of all variables at the second last node point of the previous trajectory. This increases the chance of the optimizer actually finding a solution because of the small movements that take place when the foot is close to the ground. Randomizing this seed would make it very difficult for the optimizer to find a solution. Okay, so here we can see the dual model physics engine in action. The robot was dropped from a height of z is equal to 0.5 meters to test if the physics engine could sustain multiple contacts, proving that the models could be used successfully and switched to and from. In this animation, we can see that the robot falls to the ground, initiating the contact model, and it launches up again, initiating the non-contact model. So it just repeats this process. And we can see that there's a fixed time step applied when the robot is in the air and a variable time step when here's the time step when the robot is in contact, allowing the contacts to actually be captured correctly. So this is a successful result and validates the two models working in conjunction correctly. So One of the main advantages of this physics engine is that controllers can be designed, implemented, and tested on robots with an accurate ground reaction force model. So a knee controller was designed using the following structure, and the controller was designed using trajectory optimization itself. So using exclusively the contact model, but with 150 node points, we used bounded variables were used for the gains and thrust force, and an additional constraint for the final Z height set to 0.9 meters above the surface was created. So we can see that the controller was tested. It was dropped from 0.8 meters above the ground, and the optimizer, having full control of these variables, successfully picked the gains and the thrust force for the controller. The controller was then implemented in the dual model physics engine and produced the following results, as you can see on the slide. We can see that the robot falls and hops up due to the torques applied, and the impulsive ground reaction force is captured correctly. So another amazing capability is the dynamic environments that can be modeled in this physics engine. And just as a reminder, no contact order is to be enforced. So when I say no contact order is to be enforced, what I'm trying to say is that imagine you have a 10-legged robot, imagine a spider robot. You wouldn't necessarily know what is the way that this robot should move. So you can't necessarily tell the physics engine, like, take one step here, take one step here. So we don't know, is it going to be in the air, is it going to be on the ground? So we don't want to tell the physics engine this is what's going to happen. So we don't want a contact order to be enforced. So this physics engine actually has that functionality and capability to not enforce a contact order, which is quite a significant achievement. To demonstrate this, a staircase was modeled, very simple, and it was done by introducing a ground height variable that was initialized to 0 meters. And after the robot made its first contact with the ground height was then increased to 5 centimeters, and consequently this creates a step. So the same knee controller that you saw in the previous slide was used, and the gains were just tuned to be more aggressive, allowing the robot to jump higher so it can actually reach the next step. After hopping, the robot leant a little bit far over to the side, which made it difficult to hop up on the succeeding jump. So an aerial controller was then implemented, constraining the shin angle to 135 degrees. So we can now move on to the staircase test, and you can see the robot in action. You can see that the robot and its changing stair heights are shown in this animation over here. And it is amazing to see the multiple contacts that occur when the robot touches the ground at 0 meters. Because you must remember that we're not telling the robot to do this. We're telling it this is what we want to achieve. And the actual optimizer is then performing this action. So the fact that there are multiple contacts there means that the optimizer is then deciding that that is the optimal solution for this problem. So this is the demonstration that, the optimal solution is not necessarily a one-touch hop. And we are reminded that multiple contacts as well as foot slipping is supported by this physics engine. And we can really make use of this information to further study legged robots. So, conclusion and future work. This project proved that a novel physics engine to test impulsive legged robots can be created. The physics engine models the dynamics of the robots, the environment, and the interaction between these two using trajectory optimization. It transitions between a contact and a non-contact model to solve trajectories quickly and accurately. And it was shown that controllers and dynamic environments can be tested, which is a fantastic result that can be used to further research legged robots. So I would just like to say thank you to the CSIR for giving me this opportunity, and thank you for all of you for actually listening to me about my passion. So I now open up the floor for any questions. Thank you.
Thanks, Stefan. That was very interesting. Are there any questions from the floor? Yes, we have one.
Okay, my question might be out of content, but I would like to know if your robot, is it a self-powered? Obviously, it needs energy to operate. Is it a self-powered? Then my second question is, how long will your robot operate, like the lifespan of your robots? Thank you.
Sorry, can you just repeat that last question? How long will the robot operate?
Okay, can you please briefly tell us about the lifespan of your robot? Lifespan. How long can it operate, like in months or years?
Sure. So, so one thing to remember is that this research is completely in simulation. So the robot that you're seeing there is not an actual robot that has been deployed. So maybe that gives you a bit more context for your questions. So this is essentially a platform that can be used to test legged robots in the future. Other people can use this platform. You can test your robot using this and develop things. And you can develop extremely complex systems because this uses trajectory optimization. The one thing is that with the increased complexity that this platform allows comes added complexity in the design. But it really has, the sky is the limit. But yeah, thank you for your questions.
Thank you very much. Are there any other questions? Okay, there are two, one over here and one at the back.
Thank you for a great presentation. I want to check in terms of application, have you applied this in any industry? And which type of robots did you use, or the industry, what was it working on? Thank you.
Thank you for your question. So this research is extremely new and is on the cutting edge of robotics. So this is a novel physics engine that has never been created. So this has not been tested on an actual robot just yet, but it is a great step forward for robotics, specifically legged robotics as a whole, because oftentimes in current research, people will maybe test a robot in simulation, and let's be honest, sometimes getting something to work in simulation, you can kind of massage things and get things to work, but when you go into the real world, things break. And this physics engine, with its accuracy, truly allows the design of legged robots with aggressive, impulsive, and really quick ground reaction forces. This has not been used in industry just yet. In fact, in Africa, we have so few legged robotics research groups because it is so new and so expensive to do as well. But yeah, thank you for your question, and hopefully this will be used in the future.
Thanks. Okay, one final question at the back, and then we can do the rest afterwards.
Sure.
Yeah, I have two questions. The first is related to the contact, how you modeled the contact, because I noticed that the contact was impulsive and it had multiple contacts.
Yeah.
And like I know with the epsilon relaxation techniques you used, there's a bit of conflict to that. So like it's not as easy to model contact with epsilon.
No, it's
or
really
force
not.
contact. And then the second question is like, is there a TRL level attached to this? Because I know this is incredibly novel research as well. So yeah.
Yeah. So with regards to the contact, the way that the contact was done is there's a switch between the non-contact and contact model, and the reason why this physics engine is so effective is because when you run the non-contact model, there's no complementarity constraints. Just for context, the complementarity constraint is just when two variables are equal to 0. So that means that you might have the foot height, for example, and the ground reaction force. Both of those have to be 0 at some point because you can't have the foot in the air and then have ground reaction force. So the non-contact model has no complementarity constraints. So it runs very quickly. And what we do is we will run the non-contact model, and even if it goes through the ground, we will then do an analysis after the trajectory and determine just before the robot is touching the ground, switch to the contact model. And that's how, even though the contact model is very complicated and takes a lot of time to do, we're only running it for such a short period. So we use epsilon relaxation with the contact model, and essentially we just start with a very high epsilon value, maybe 1,000 or whatever the case may be, and this allows for a very rough solve for the optimizer, and then we will resolve it again and reduce the epsilon, and that's how we get a more accurate solution each time. And then we keep on doing this until we reach a point where essentially the optimizer cannot find a better solution, and that's the final solution that we find. And I'll answer your second question privately afterwards.
Okay, thank you very much. I think there are a few other questions as well that you're welcome to ask him afterwards. Thanks for your presentation, very
Thank you.
interesting. That was your 20-minute time. You did well. Okay, thanks. Our next speaker is Nosipo Mutwetwa, and she'll be presenting on towards developing a broadband infrastructure dashboard framework. Thank you.
Okay, greetings everyone. My name is Nosipho Mthethwa. And the title of my presentation today is Towards Developing a Broadband Infrastructure Dashboard Framework. Okay, so this is the outline of my presentation today. I will start by giving an introduction, give you the motivation and the problem area. Then I will give you the research objectives, followed by the methodology, and then show you the adopted framework. And then I will give you the benefits of having a broadband map and show you the envisaged dashboard, and then I will conclude. Okay, so broadband mapping is when the deployment, coverage, and quality of broadband is collected and presented for a geographical area. There are 4 different types of broadband mapping, which are service mapping, infrastructure mapping, demand mapping, investment, and funding mapping. So service mapping deals with, so it presents the service providers in an area, including the available bandwidth and the quality of the service provided. Infrastructure mapping shows you the detailed infrastructure in an area. So it shows you the detailed broadband infrastructure in an area, and it also shows you infrastructure that can be used to host broadband networks. So demand mapping shows you the demand of broadband in an area. It also shows you the expected speed and bandwidth, and also the user's willingness to pay. Investment and funding mapping focuses on funding for broadband projects. So for this research, we focused on infrastructure mapping. The technologies that we focused on was fiber, mobile broadband, Wi-Fi, and TV white space. ADSL, VDSL, and satellites were out of scope for our research. Okay, so this research was motivated by the lack of a centralized system that shows the broadband infrastructure in the province. This system would show the connectivity layout by converging the current broadband maps from the different service providers. So this would help in the extending of the broadband infrastructure in the province by ensuring that infrastructure is deployed in areas that are lacking. Another huge motivator for this research was the Gauteng 4IR strategy, which indicated a need for a single view of the province's broadband infrastructure. So the research objectives for this project was to use an ICT system to facilitate a process that will inform user needs while enhancing their decision-making process. This was done by investigating existing broadband maps, both internationally and locally. It was found that many European countries are obligated to have broadband maps, and also other countries outside of Europe also have broadband maps. It was found also that in South Africa, there is no single view for broadband infrastructure or service. We only have we only rely on the coverage maps from the service providers. So the objective of this research was to develop and implement a centralized broadband infrastructure dashboard. Okay, so the adopted methodology for this research was the methodology of developing a conceptual framework. So we conducted a literature review and then identified the isolated the important variables for the project, and then we developed a framework using the identified variables. So for this research, the identified variables were the required human resources, the data, software to be used to implement the project, and the hardware resources and infrastructure. So there were 3 frameworks that we identified for this research. The first one was the Readiness Framework, the Interoperability Framework, and the Usability Framework. So the Readiness Framework speaks to the system and its ability to accept and sustain change. The interoperability framework was identified due to the need of systems to exchange data to implement the project. Since data will be received from different service providers, it is expected that the data will be in different formats, and an interoperability platform is crucial in order to convert the different data into a single format to be used by the developers. And then the usability framework just describes the user's activity and experience while interacting with the system. So the readiness aspects that need to be addressed are to facilitate sustained change, enroll stakeholders, manage and adopt and influence change, develop capacity, deploy and manage the system's operations. So the readiness framework also ensures that stakeholders are identified and that the vision is clearly stated to them. It also ensures that a person is assigned to oversee the project, to make sure to deal with non-compliance issues and to tell all the stakeholders what is expected from them. The political climate also needs to be checked for every implementation of a project, and it is also addressed using the readiness framework, and also the community's receptiveness of the anticipated system. So these are the interoperability categories that we identified, which is data, storage, and security, and the human resources. So with the data file type, it is expected that different service providers prefer saving and storing their data in different formats. So a platform would be needed to convert all the data file types into a single file type that is going to be used for the project. And there are four different methods that were identified in which data could be collected with. So it is using email, which is viewed as insecure and also not feasible for large volumes of data. We can also enter data on a portal, and that is only feasible for smaller companies, and it would just require a lot of effort for mid-sized and bigger companies. The web services also requires a lot of effort from companies, as it would require them to embed their data it would require them to upload their data on a server and then allow the GIS specialist to embed the data on our map. And then lastly, it would be to upload on a server, which can be viewed as secured only if a secure protocol is used. So with the storage a web server or a server, a network attached storage, and cloud services can be used. So with the server and the NAS, the storage is fixed, and that could be a problem if the storage will not allow all of the data received to be saved. With cloud services, the storage can easily be extended if more data needs to be saved. And for security, in order to make sure that the service providers are comfortable with sending us their data, we need to make sure that we show them that their data is going to be secure using a software and a hardware firewall. So the human resources that are required were identified as an administrator, a software developer, a GIS specialist, and a telecom specialist, but that is dependent on the size of the project. So with usability, it has two spheres, which is the system and the usability measures. So when the designer is designing the system, they have to keep in mind the user, the task, the equipment, as well as the environment. So the system should perform they should perform the user needs while also addressing the designer's interests. So it is also expected that the system performs the task that it was designed for. It is also important to make sure that the equipment in the environment is user-friendly for the user. So the usability measures are the effectiveness, the efficiency, and satisfaction. So effectiveness measures the extent to which the user can achieve the goal with accuracy and completeness. And efficiency measures the level of effort and the use of resources that the user would need to achieve the goal with effectiveness. And then satisfaction shows the positive association and absence of discontent when the user is interacting with the system. So the benefits of broadband mapping are to aid in the deployment of broadband infrastructure and also to indicate areas that have outdated infrastructure in the country. It will also help to avoid redundancy in infrastructure deployment and encourage resource sharing. It will also help the government to provide accurate statistics to the ITU. So this is the envisaged dashboard. As we can see in block A, we will have the map displayed, and then in block B, that is where the user would be searching, that is where the user will search for their address. So we identified a business user and a private user. Private users would be able to search for their address or a smaller area, and the broadband infrastructure in that area would be displayed on the map in block A, while the business users would be preview of some extra information like the percentage of penetration of broadband in an area. And then in block C, that is where the user would be choosing the broadband technology that they want to see. So in block C, the user would open a window like this one where they will select the technology that they want to see. And then in block D, that is where all the service providers are going to be displayed for an area. Okay, so in conclusion, the three identified frameworks will contribute to a single framework for the development of this dashboard. Broadband mapping is important, especially in developing countries, to indicate where broadband infrastructure has not been deployed, and that will help to decrease the digital divide. So next on our agenda now is to develop a prototype or phase one for demonstration, and then also to do a study on the 4IR, on the role that the 4IR is playing in advancing broadband mapping, especially in developing countries. We'll also check for the social and business benefits of having a broadband infrastructure map available. Thank you.
Thank you very much, Masipo. That was very interesting. I have one question. This system, will it be able, after you've integrated with all the different ISPs, will it be able to automatically detect where there's no coverage at all or lacking coverage?
Yes. Yes, so the idea is to use the data provided to show where there's no coverage. It will not be automatic. We would have to directly program it at this point. But yeah, or we will also need to get an update from the service providers if there has been any changes. Maybe if they lost a connection in an area, we would need to be informed, or if they have deployed more infrastructure in an area.
Okay, great, thanks. Very, very interesting. Are there any questions from the floor?
Okay.
formally transcribe areas in the extended, they will tell you no, no need to do this. So there is no way we can provide analysis.
Okay, so can you please just repeat your question?
How will you convince?
Okay, so most of the companies already have their coverage maps online, and we also have had meetings with a stakeholder, and they actually showed interest in yeah.
Okay, great, thanks. Are there any other questions? Yes, we have a question over there.
Sorry, look, I'm glad you mentioned that most of the service providers they are mapping online. So I wanted to ask you, what's unique? Because I've seen this before, and I want to see what's so unique about this dashboard.
It has all the service providers in one dashboard. So you wouldn't have to go to Telkom and then jump to Cell C and then jump to Vodacom. You would see all of them in one dashboard.
Thanks. Another question?
So then who would be the user? Who would be the person, who would the information that the dashboard provides be of benefit to?
Okay, so like I mentioned, the public and then mostly the government, where they will see, so they will be able to see areas that do not have infrastructure, and that is where they are going to encourage deployment, or that is where they are going to go and deploy their infrastructure.
Thanks, yeah, that would be very nice. I think it will help a lot of people as well to get this going. Do you have a planned date when you're going live with this or not?
Currently we don't, because... Okay, yeah, currently we don't.
Thanks, Nosipo, that was very good. Okay, our final presenter is Lying Lawrence, and they'll be presenting on cross-platform development, strategies to optimize resources for development, efficiency, and user accessibility. Enjoy your presentation.
Stand here. Here. Okay, cool. Good morning, everyone. My name is Lang. Stand straight. Good morning, everyone. My name is Lang Lawrence. I've been working at the CSIR for a while now, and in that time, I've worked on some very interesting projects in data science, in natural language processing. In GIS applications and in e-health. And today I'm going to be talking about cross-platform development mainly. And the reason I chose this topic is because on some level this is something that's affected all the projects I've worked on while I've been at CSIR. There will be three main parts to my presentation today. First, I'll be discussing concepts that relate to the end user perspective of an end user of any technology, and also some development concerns, but those development concerns are ones that would affect the user's experience. Then I'll be talking about 4IR in industry. Of course, this is the theme of our session. And in this part of the presentation, I will focus on ways to improve things from the development point of view. And finally, I will end with a section on innovation and entrepreneurship, which is, of course, the theme of our entire conference. And I will give some community perspectives of these technologies. Okay, so we'll start off with a case study. I think in 2020, Checkers launched their 6060 app. And this is a brilliant app. I used it myself. Basically, it's a delivery service. And this was especially useful when the pandemic was at its peak, you didn't want to go out, you can just get them to deliver your groceries straight to your house. This service was available on Android devices through the Play Store and on iPhone devices through the iStore. And then at some point, I opened it on my phone and it said, we don't support your version of Android anymore. So I went onto the internet and I tried to see if I could get the service online, and it's only available on mobile. So once again, I think it's a brilliant service. I just don't have access to it, and I'm sure a lot of people are in the same boat as me, and potentially they are losing out on a big market. Another quick case study is a company called Quibi, short-lived company. They were trying to be the Netflix, but basically tailoring their content specifically for mobile devices. Of course, they launched, and soon after that, the pandemic started. Suddenly people weren't watching things on their phones while they're on the bus. Now they're all at home. And again, they only developed for mobile, so they were not very flexible with their strategy on that point of view. And they are not operating anymore. So in both these cases, it comes down to a question of accessibility. And very interesting, this kind of follows on from our last speaker who's speaking about coverage. So at another layer below coverage, you can have coverage, but can you access the services that are available on that network? And just to give a brief overview of the different end user environments that exist, of course, probably the original one that we're all familiar with is the desktop. And Windows, obviously, the most popular operating system, I think. Also very popular is macOS. And then you have Linux-based systems, such as Ubuntu, and also more recently, Raspberry Pi operating systems. And there's some new ones coming on the market, such as Chrome operating system. And then you also have mobile devices, such as iPhones, Samsungs, and other phones, which generally use the Android operating system. And then previously, we had things like Windows phones and BlackBerry phones, and these are not even relevant anymore. I don't think they work anymore. They're not supported. And what's common to both of these devices is the web. Both phone and desktops and laptops, they all will have a browser of some sort on them. And the most popular browsers, the ones that we know of, are Chrome, Safari, Firefox, Microsoft Edge, and once upon a time everyone used to use Internet Explorer, but this is also end of life now. It's not being supported anymore. So it's a question really like, how are you accessing services? How can you access services? So I'm now just going to explain different types of applications that exist, starting off with web applications. So you can go onto any website. This is an example of a web application. If it's very well designed, it will be responsive. So depending which device you're on, the screen will change and everything will still work. And web applications are dependent on browsers. So you might get different experiences across different browsers, but should mostly be stable, similar. You then also get progressive web applications. So these will work on any web browser, and including desktop and mobile devices. And they may have extra capabilities such as offline access, push notifications, these kind of things. Also, you can go into your browser on your phone. You can click the three dots, and there should be an option to download to your home screen. And then you have a web application that it looks like it's a mobile application, and it behaves mostly the same way. You then get native applications, and most commonly and most well-known, I think, obviously, mobile applications. And these ones you will access through generally a specific type of platform-specific application store. I mentioned before Google Play Store, the iStore for iPhones. And if you're but also this does also include desktop. You can build natively for desktops. An example there would be PowerPoint. And generally, you can tell, say, if you use PowerPoint on your computer, you can now also use PowerPoint on the browsers. But generally, I still find the PowerPoint on the computer is just a little bit better. But it is at least available on the browser. And then you get hybrid applications. Now, hybrid applications is a new kind of approach, and I'm going to go into a bit more detail. There's two different approaches to hybrid. You could do hybrid with a mobile-first approach or hybrid with a web approach. Now, just to maybe give an overview of how native application development will work, this is a more traditional approach. So since you are building for a specific end-user platform, you would then need different teams to program for those different platforms. Generally, it would maybe be difficult to reuse code across those different platforms. So there are benefits, of course, to using this type of approach. As I mentioned, performance is a bit better, as in the case with desktop PowerPoint. You have rich native libraries that are supported by the provider. However, obviously challenges, you will have longer development cycles, higher costs, these kind of concerns. Hybrid application development, on the other hand, the philosophy is you'll write once, you'll have one code base, and you will then be able to deploy that code onto multiple different platforms. So you can see, in this case, you only have one core team. You're using people who have web development experience. So some benefits of hybrid application development. As I said, you have efficiency, you have very high design consistency across the different platforms, and this is because everything essentially is running in a browser. You leverage existing skill sets. There's a lot of people who are familiar already with web development, and in a way it's future-proof. And what I mean when I say this, you can look at the picture there. On my old tablet even, if I open up the YouTube app, which is a native mobile app, it says your version of YouTube is no longer supported. Please go and use YouTube on the browser. So eventually native applications aren't supported, and then you fall back to the browser anyway. So that's what I mean when I say future-proof. However, challenges of using this technology, generally there'll be system overhead, so you have to learn a new framework. And you have dependencies now in other parts of the chains. Let me move on to some more examples. So one approach of hybrid development is native first approach. I'm not going to go into too much detail here, but basically you can see that the JavaScript, the code that you're writing, will interface directly with the native hardware through a bridge. And just contrast this to a hybrid web development approach where your code is running within a browser, and then if you need to connect to some device, some feature on the device, such as a camera or an accelerometer or something, then that would be done with the browser communicating with the native layer of the phone directly. So that's the gist of the difference between those two approaches. So just an overview. As I said, native, you're going to have totally separate code bases per platform. So if you're going to develop an Android app and an iPhone app, those are two separate code bases, two projects almost. If you're going to use a hybrid native approach, you'll be able to deploy to iPhone stores and Android stores, and mostly you can use the same code, but for certain special applications, maybe you would have to have different code bases just for that. Maybe something like an accelerometer or something. And for hybrid web, you have one code base, your UI will be the same, and you can deploy almost anywhere on the browser or on platform-specific stores. All right, we'll now move on to 4IR and industry. So these are just some things I've noticed about, I've worked on a lot of projects, developed a lot of applications, so things I think that could maybe be improved in the way we've been doing things. Firstly, I'll start explaining something called component-driven development. So just a quick overview of front-end development. So this is different to back-end development. I'm not going to talk about back-end development today, things like microservice architecture and all that. Front-end development is all about the user interface, what the end user sees on the web page. And basically, everything you see on a web page is a box, or a box within a box. Even, for example, you'll see there's a circle there in the corner. That circle will be inside a box. And that's how the page is built together. It's just all Lego, basically. Now, if a new developer is coming on a project, generally it's difficult to get that person up and running. They have to set up a whole bunch of things. And a different approach to this would be you can get a person to just create one box instead of a whole application. Just work on one box, and we can, just drill down and give that person more specific guidance, and he can work in isolation from anything else in the project. And then at a later point, we can add that component that that person's developed into the app. I was going to give a demo of a nice tool, but I think I'll leave that out and maybe come back to it at the end if there's any time. And some features of this kind of approach, if we set up a central repository, then we have easily accessible code to share across projects. If I wanted to use code from another project, even within my group that I'm not working on, it's quite difficult to do that. I have to get permission, I have to set things up, and then I have to look through code and find the specific piece that I want. But if we use components, it's easier to separate these concerns and to improve accessibility for developers. And there's major benefits to that. We can reuse a lot of code across projects. We can cut down a lot of development time that way. And also because we're developing on an individual component level, you can improve your testability of code. You can be more sure that your code won't break, just that little box that you were working on. So I'm going to just quickly explain a normal development process that you will follow if you're making an application. I know a lot of you are all inspired after Daniel and Dima's talk yesterday about entrepreneurship, and you're full of ideas now. Maybe some of you want to make your own app. So normally, if you're making an app, you will follow a process where you will do a business analysis, you will understand the market, understand the needs of the people, then you will define requirements and get more specifics, some specifications for your solution. Then you will do a mock design of the application, what the final thing will look like, and then generally you'll start development. And normally something we do there, we'll maybe go buy a $20 starter, what's it called? A template, a $20 template, and then we take the things out that we don't need and start to customize. That's normally the approach that is taken, that I've seen a lot in application development. But now what I'm suggesting, if we include component-driven development into our workflows, then once we have an application design, we can then identify specific components, and in parallel, we can build the shell of the application. So this is normally called the plumbing. It's really a question of how the data will get into the specific components. And in a separate workflow, we can develop components themselves. And also this way, if you're developing a lot of applications, you can then identify this component already exists. We developed this in another project. We don't have to develop that again. And then at the end, you will have to integrate these two things together. Okay, cool. Another very important thing, once your project goes live, you have users all over the country, all over the planet even, and you need to track errors. So here's an example of an application that does error tracking. You can see the frequency of the errors, how many times it occurred, how many users it affected. And on an individual error level, we can get what device the error happened on, the stack trace, everything. I just want to emphasize this is very important because normally you need a call center. If a user experiences an error, you'll call the call center. The call center will have to call you, explain it. This way we take out a lot of that middleman work. It makes it a lot easier to fix problems. Here is something also that's changing the way people work across the world. It's called code generators. And the basic idea is this is code that writes code. If you go back, an early implementation of this is, for example, a wizard. You remember the early days of Microsoft. You had that little clip. We would talk you through the process. But nowadays, we've now combined this with AI, which has been trained with billions of lines of public code online. And the code is now writing itself in a way. And essentially, it's not taking the place of the program, but it's helping the programmer to work faster. And if we don't adopt this kind of technology, there's a chance we will get left behind. Just finally now, we will talk about innovation and entrepreneurship. Now, especially in South Africa, there are many startup accelerators and different innovation labs. One local one is called the M Labs. They have 3 main pillars of their business: identifying talent, improving entrepreneurship, and technology. And these guys, we did actually talk to them for one of our projects just to get some advice. And this is an opportunity, I think, to grow networks. And finally, also the Deep Learning Indaba X. This is a conference that will be coming up, be hosted in Pretoria this year. It's called the Deep Learning Indaba X because there's a main conference that happens in Africa, and in each country in Africa we have our separate conferences. And so I encourage you all to apply. Applications are not open yet, but you can give me your details and I'll let you know as soon as it's open. Cool. Finally, I'm just going to talk about my experience that I had working on the vaccine certificate project. So in this project, we got our requirements from the client that we need this service so that people can travel overseas easier. It was very important. We had a lot of public scrutiny. Every morning in our meetings, we would start off, the manager would say, "Are we trending on Twitter yet? No? Okay, we are doing well." And so we chose a hybrid web approach because we wanted to maximize the coverage. And in order of what we deployed, we first deployed a web application, then we deployed to the Android store, and we didn't deploy to the Apple store, but we could if we wanted to. I'll just show you some quick graphs. So this is the traffic, basically. These are certificates that we served. At the start, there were much higher numbers, the ones that didn't get through, because we couldn't deal with the traffic. And you can see there's a drop there. In that drop there, we had to optimize our application, and then after that, it was fine. But in that drop, there was a call from the president who said, "You need to fix your application. Why is it not working?" So it added to the stress that we all had to deal with in this project. Finally here, just to bring it back to really what I started with, is how people accessed the vaccine certificate. And overwhelmingly, 38% were on Chrome mobile, on the phone. 22% were used Chrome on the laptop. 15% used a combination of Safari, which is an Apple browser, Chrome on Apple phone, and also I think just the Mac users. And then interestingly, this Chrome mobile web view, I'm about 80% sure that was 2.5% of the users, and I believe that those are the users that used the Android app. Even though the website was available, they still chose to download the app. And I'm not sure, but I think maybe those are the ones who were scanning the certificates rather than downloading the certificates, because they will maybe have to use that app every day. So it makes sense to download it. Sure. Some conclusions. What's the best approach to use? It really depends on your use case. Maybe those, the 5% of, or the 15% of people who use Apple phones, you want to make an application specific for them, and you know they will charge, I mean, they will pay, say, $50 per month for your service, but then your service has to be really good. For us, I work in e-government. Our concern is always to maximize accessibility. So the hybrid web approach makes the most sense. Also, if there are cutting-edge applications, maybe they use accelerometers or new technology on the device, then you would maybe go a native route. I think if we create community of practices within CSIR and within the broader community around these technologies, we can grow faster. This way we can also share knowledge easier, and through institutional partnerships we can also reach existing and surrounding communities. Sorry. And finally, just acknowledgements. I just want to thank my team that I worked with and the guys in defense. You guys are amazing. It's great to work with you. It's great to learn from you. And yeah, I would like to thank the CSIR for the opportunity to serve the country. It's really been an honor, I have to say. That's the end of my presentation. I don't know, do we have time for comments and questions? No? Okay, please come talk to me afterwards. We can go get some lunch. Thank you.
Thanks, Lang. That was really very interesting. Sorry, there's no time for questions now, but please do ask him questions afterwards. We're running a bit behind schedule, but I think we can have a quick body break. I think if everyone can be back here at 12:05, that would be fantastic. Then we can start the next session. Thanks.
Agriculture. And the questions that we received. Can I just, yes, can you quickly open these slides? I want to check.
To stop sharing.
Yes.
And shows the meta-analysis of 1,090 studies on primarily wheat, maize, rice, and soybean. And these shows that, like, over time, climate change is likely to have drastic effects on crop yields. Next. Plants have been used as a source of bioactive compounds for medicinal reasons for generations. Allopharax is a medicinal plant indigenous to the Cape coastal regions of South Africa, and it grows in various environments. Some of its traditional uses include being used as a laxative to treat skin disorders and cancer treatments. And in recent years, it's been incorporated in food and cosmetic products. Sutherlandia fruitensis is a medicinal plant found in the drier parts of the southern Africa, and it is traditionally used to treat wounds, chickenpox, stomach ulcer, and rheumatic diseases. Allopharax and Sutherlandia fruitensis are evolutionarily adapted to thrive in environments that experience high levels of abiotic stress, and they host a wide range of microbiota, including actinobacteria. These microbiota can inhabit the plant as epiphytes, endophytes, or rhizospheric bacteria, and they all play key roles in the plant fitness, with only a small fraction known to cause diseases. And the overall interaction is mutualistic. Actinobacteria are gram-positive, spore-forming aerobic bacteria with high GC content. They represent the largest taxonomic group within the domain bacteria, and they are ubiquitous in nature, but are mostly found in soil. Actinobacteria produce beneficial secondary metabolites, with over 50 genera extensively explored for their therapeutic applications in human and veterinary medicines, and they're also used in the industry at large. Actinobacteria colonize the rhizosphere through antagonistic and competitive interactions against other soil microorganisms, and consequently they affect the plant growth directly or indirectly. They do this directly by promoting plant nutrient uptake through mineral solubilization, phytohormone synthesis, and ammonia and siderophosynthesis. And they do this indirectly by providing plant protection from soil plant pathogens through producing antibiotics and antifungal properties, and through secondary nutrient acquisition by the production of extracellular enzymes. So direct and indirect plant growth promotion activities lead to enhanced resistance to biotic and abiotic stress, and it leads to improved physiological, morphological, and chemical properties of the plants. Phaseolus vulgaris is a legume crop with high quality nutrients. It provides 15% of protein and 30% of caloric requirements of the global population. Within the legume family, the common bean is the most important crop for human consumption after soybean and peanuts. However, it is highly affected by drought, salinity, and extreme temperatures. And these factors reduce its plant growth and productivity by affecting the plant physiology, plant morphology, and plant biochemistry. While the use of agrochemicals is a relatively reliable strategy for improved crop yield and protection, overusing them can have a negative impact on the environment and leads to increased pathogen resistance. Additionally, these compounds have a detrimental impact on the soil microbes, which ultimately affects the crop's nutritional status. Plant growth promoting bacteria form a part of the plant microbiome, essential for both direct and indirect plant growth promotion strategies, and they play a significant role in the health and growth of the plants that they inhabit. Many microbes have been extensively studied for their plant growth promoting properties, but actinobacteria have only been increasingly documented over the past 2 decades for their promoting traits. So the overarching research aims are to screen actinobacterial isolates for plant growth promoting activities, to perform a phylogenetic analysis of the isolates, and to develop microbial inoculants for plant growth experiments, and to perform plant growth experiments on the common bean seed. So we used glycerol stocks of bacterial isolates that were isolated from A. ferox and S. frutensis, and they were cultured on ISP2 medium. Then DNA extraction was done, and 16S analysis was done, and the 16S sequences were used for phylogenetic analysis. And then the plant growth promotion assays, both the direct and indirect were done, and then based on the activity profiles of the isolates, we chose the 7 best performing isolates on broad range activity, and we used those to develop the microbial inoculants, which were tested using plant growth trials, and the resulting plant material will then be used for an inductively coupled plasma analysis and for gene analysis. A 16S rDNA phylogenetic analysis was conducted by running the 16S sequences on the EasyBio cloud database, revealing that the top hits with 99 to 100% similarity percentage were strains of known Streptomyces species. So the isolates were screened for both direct and indirect plant promotion activities using culture-dependent methods. Iron deficiency in crops results in iron chlorosis, which is the yellowing of the plant leaves, contributing to micronutrient deficiency, thus making them sensitive to microbial infections. Siderophores produced by plant growth promoting bacteria help increase the uptake of iron by making it available to the plants to use, which ultimately aids in nutrient acquisition and plant protection. And then figure 6A shows the siderophore activity, and it is symbolized by the zones of hydrolysis around the colonies, as seen here. Phosphorus is essential for plant growth and development. It is involved in a number of key plant functions, including energy transmission, photosynthesis, sugar and starch processing, and nutrient flow throughout the plant. Microbes can solubilize inorganic phosphorus to make it readily available for the plant to use. And then figure 6B shows, what did I just do? Okay, figure 6B shows the phosphate solubilization, and the zone of hydrolysis around here shows the solubilization of the phosphate basically by the colony. Nitrogen is an essential element for plants since it is a component of numerous plant structures as well as internal and external metabolic activities. It is required for the formation of amino acids, which serve as building blocks for plant proteins, and it is a nucleic acid component that is required for DNA synthesis. Nitrogen is also important for plant processes such as photosynthesis. Plants rely on symbiotic organisms to fix atmospheric nitrogen and make it usable for them. So ammonia produced by plant growth promoting bacteria has been shown to supply nitrogen to their host plant, thereby promoting root and shoot elongation. Figure 7A shows the ammonia production of the isolates with concentrations ranging between 26.7 and 98.9 micrograms per milliliter. Indole acetic acid is a phytohormone that belongs to the auxin family, or auxin class, sorry. Auxins promote cell growth and elongation, and studies have shown that bacterial indole acetic acids increase root surface and length, thereby providing the plants greater access to soil nutrients and increased water uptake. And figure 7b shows the indole acetic assay of the 16 screened isolates, and the concentrations ranged between 0.36 micrograms per milliliter and 1 microgram per milliliter. Plant growth promoting bacteria are known to produce a suite of extracellular enzymes. So extracellular enzymes are required for the breakdown of complex compounds to simple molecules that are readily available for plants to use. They target nearly every macromolecule, including proteins, by the activity of proteases, carbohydrates by the activity of amylases and cellulases, and amino sugar polymers by the activity of chitinases, to list a few. All 16 isolates could degrade cellulose, chitin, and starch, with zones of hydrolysis ranging between 20 to 90 millimeter diameter for cellulose, 8 to 56 millimeter diameter for chitin, and 2 to 20 for starch. And out of 16, only 1 had no visible xylanases activity, as shown on the graph there. And only 4 out of 16 showed pectinases activity against citrus pectin. So based on the broad range activity of the tested isolates of the actinobacteria, 7 isolates were selected for inclusion on the development of the microbial inoculants. The plant growth experiments were conducted on surface sterilized seeds that were submerged in the developed microbial inoculants for 6 hours before planting them. The growth experiments were conducted with 3 replicas for each sample, and the control sample was mock inoculated with just ISP2 broth, and all the plants were grown at 22 degrees Celsius for 21 days on 18-hour light, 6-hour dark cycles with regular watering. And the plants were harvested on day 21. So 2 of the exciting results were the BKS1 and BKA7 sample. All 3 replicas of BKA7 and BKS1 inoculated samples had root and leaf development, with the average root weight of 568 milligrams for BKA7 and 606 milligrams for BKS1, and they had more cell mass in comparison to the control plant. And overall, the actinobacterial inoculated plants showed enhanced growth compared to the control plant, as seen visually here and by looking at the table there. So the experimental results show that actinobacteria isolated from Alloferox and Sutherlandia fruitensis have numerous plant growth promoting properties. In growth trials, the seeds treated with the actinobacterial extracts enhanced growth in comparison to the control plant that was not inoculated with the actinobacteria. So several isolates, as shown in the previous slides, have phenotypically confirmed to impart plant growth promoting qualities for crops. This includes the increased root development and elongation. The study shows that actinobacteria isolated from medicinal plants promote plant growth and are a promising source of plant growth promoting bacteria. So a second set of growth experiments is currently being conducted but under stress conditions, which are salinity and osmotic induced stress. This is to check whether the actinobacteria provide protection to the plant under the mentioned stress conditions. And the next part of the project is to use the plant material to conduct an ICP analysis to determine the plant nutrient uptake and accumulation of major, minor, and trace elements. And the future work includes conducting a genetic analysis to identify the impact of the inoculants on plant stress tolerance. And I'd like to thank my supervisor who helped throughout the project, and also the DSI CSIR IBS program for the financial support. And yes, that is it.
We do have 2 minutes for questions. Go ahead, sis. Well done.
Hi, congratulations on not fainting.
Thank you.
I just wanted to ask a quick question. How readily available are your inoculants, and how marketable is your process?
Readily available, I'd say they're readily available, but not necessarily like the ones that I use, because basically the inoculants that we used are bacteria that were isolated from the medicinal plants that I previously mentioned, Allopharax and the Sutherlandia frutensis. So if you isolate for yourself, maybe you might find actinobacteria that you might use for inoculation. And the second part of the question, marketable, I'd like to believe it is quite marketable, but there's still further analysis to check whether the bacteria that we used, basically the isolates, are novel or not, because there are streptomyces that are being used in the industry as plant growth promoting bacteria. So the further analysis is to check that part of the marketability, if they're novel or not, considering that they are actually isolated from medicinal plants. Yes.
Any other question? Thank you, Busi. My list of questions is too long. It needs a lecture. Thank you very much. So I won't ask now. Thank you very much. But your talk is very interesting.
Thank you.
But can I ask, Busi?
Yes.
So does this these inoculants, would they help if you like, for instance, I think in your abstract you mentioned that this will help a lot because we now have climate change. So do you think these inoculants would improve our plant growth when we are experiencing problems with climate?
The second part of the growth experiments is to address that part.
Okay.
But I'd like to believe so, because there are several streptomyces, which are actinobacterial isolates, that have been extensively studied that do provide protection from the impacts of climate change, which are salinity and drought.
Okay, sis. Yes. Thanks a lot, ma'am. Thank you. Thank you. Thank you. Our next speaker is Buitumelo Ntwane. She's a PhD student from UJ. Her talk is titled Synthesis and Characterization of MC Titanium Oxide Nanocomposites for Removal of Lead and Reuse of Blood Fingerprint Detection. Come on stage, Buitumelo.
using?
This one.
Okay, download.
Yes. Just yeah. Move.
So you have to bring the laptop.
Yeah, sure. Move. Yeah, sure.
Thank you so much for the introduction, Doctor. Good afternoon, everyone. My name is Bitumela Antoine. I'm a PhD candidate from the University of Johannesburg, and I'm here to present the few key highlights of my PhD work titled Synthesis and Characterization of the Mesoporous Carbon Coated with the Titanium Dioxide Nanocomposite for Removal of Lead and the Reuse in Blood Fingerprint Detection. And this work is supervised by Prof. Pide Kriveshny, co-supervised by Dr. Melisi Twala, Dr. B.G. Foda Mbangam. And then I will take you through the presentation. Water is a fundamental requirement for human health or life form, including food and energy. South Africa is a water scarcity country with high rate of population, industrialization, and agriculture. Heavy metal can enter water supply as industrial and consumer waste, or even from acidic rain down soil and releasing some heavy metal into the lakes, river, and groundwater. Some of the heavy metal include chromium, manganese, lead, arsenic, and cadmium. Pertaining to harmful effect, lead stands out to be one of the highly toxic heavy metal. The World Health Organization has estimated the maximum permissible limit of lead in drinking water to be 0.05 milligram per liter, and the maximum permissible limit given by Environmental Protection Agency is determined to be 0.05 milligram per liter in wastewater. The contamination of water due to toxic lead is accountable for causing several damage to the environment and adverse side effects on human health, such as the mortality, cancer, organic failure, and may consequently interfere with the nervous system. Strong exposure may lead to diarrhea, nausea, vomiting, and gastric pain. However, there is a need to develop a method for removing lead in wastewater. The main technique which has been utilized to reduce lead content in wastewater include absorption, membrane processes, lime precipitation, electrolytic method, phytoremediation, and ion exchange. Among them, the absorption processes stand out to be one of the most attractive techniques due to low cost, flexibility, easy operation, simple design, and potential to remove lead in wastewater. There are already inexpensive and locally available agricultural waste as an absorbent, and these are orange peel, macadamia nutshell, rice husk, tea waste, banana waste, olive stone waste, and this has been used due to the larger surface area, low cost, and the easy availability. Some researchers have been developing these absorbent coated with the metal oxide. And the reason for using metal oxide was to increase the absorption capacity and also to avoid agglomeration. Most researchers have reported that the application of unmodified agricultural waste can lead to low absorption capacity, biological and high chemical oxygen demand, and total organic compound due to release of organic compound contained in the plant material. In general, modified agricultural waste exhibit higher absorption capacity compared to the unmodified form. There are already absorbent used as carbon nanomaterial coated with the metal oxide. And some of these carbon nanomaterial include mesoporous carbon, the graphene, the carbon nanodots. When they coated with the metal oxide, such as the titanium, they are used because they are non-toxic, they are non-stable, and of course they are cheaper. Nanoabsorbent has been used in a variety of applications due to the high selectivity, low intraparticle resistance, good thermal and mechanical stability, high permeability, nanoscale pores, more active sites, and larger surface area. Various approaches for preparing the nanostructured material has been reported, such as the soil gel process, pyrolysis, electrospinning, chemical vapor deposition, and hydrothermal method. Even though there is a need to develop a method for treating water, waste removed can lead to secondary pollution. So it is the intention of this project to develop low cost from the agricultural waste and reuse that waste for forensic application, specifically the blood fingerprint. So now this waste has been used in a number of applications, but now since crime is a common problem in South Africa, we decided to explore this in forensic application. With a blood fingerprint, variety of reagent can be used to enhance pattern details that may be latent. So blood fingerprint is one of the tools or evidence that can be collected during crime scene, and it can be collected from different surfaces, such as the paper and fabric, which is an example of porous, and then plastic, glass, metals, which is an example of the non-porous material. Reagents such as the comassive blue, comassive brain blue, Hungarian blue, acid yellow 7, amido black, hydrin has been used to enhance the fingerprint details. However, these are quite expensive. Now, it is the intention of this, the aim of this project to synthesize the mesoporous derived from agricultural waste coated with the titanium dioxide, to remove lead from wastewater and reuse the lead loaded on the mesoporous coated with the titanium dioxide in the blood fingerprint detection. And the objective of this project was to synthesize the mesoporous derived from agriculture coated with the titanium dioxide nanocomposite, characterize the samples, apply the absorbent for removing lead, and then find the reuse in the blood fingerprint detection. The following methodology were used. We have divided this study into 4 components. And the first component of the study was the preparation of the mesoporous carbon derived from macadamia nutshell. So macadamia nutshell were collected from the farm, and they were washed with deionized water, crushed to fine powder, and then they were dissolved in the phosphoric acid. And phosphoric acid was used as an activating agent. It was pyrolyzed at 800 degrees Celsius for 1 hour, and the sample was allowed to cool and then kept for further experiment. And the second component of the study was the mesoporous carbon coated with the titanium dioxide nanocomposite. In a glass beaker, titanium tetraisopropoxide was dissolved with the deionized water with the ethanol. And then it was, sodium hydroxide was added vigorously under stirring, and the suspension of the titanium dioxide with the mesoporous was stirred for 1 hour, and the sample was transferred to an autoclave reactor at 880 degrees for 12 hours, and the sample was centrifuged with water and ethanol and allowed to dry. The third and fourth component of the study was a batch absorption study, which is our wastewater treatment experiment, and the blood fingerprint. In the batch absorption study, we have studied different parameters, such as the effect of pH, the effect of dosage, the effect of temperature, and the effect of time to test our mesoporous titanium in wastewater. And the fourth component of the study was the blood fingerprint detection. So in the blood fingerprint detection, we're using commercial hemoglobin. The reason for using commercial hemoglobin was because in most researchers, they have reported the commercial hemoglobin. So commercial hemoglobin was dropped on the fingertip, and then it was pressed on the surfaces of different surfaces, and our spent loaded, our heavy metal loaded spent absorbent, which was the lead, loaded on the surface of our our absorbent was applied to enhance the fingerprint details. And then here is the results. So now, due to lack of time, we decided to present only 4. So the first result that you see here is the FTIR. And then FTIR was used to characterize the chemical structure or investigate the functional group within our absorbent. And then as you can see from this spectrum, the broad peak there at the 3424.91 attributes to the carbonyl group. And the peak at 1632.15, 1318, 1381.55, 1125.96, 1047.99 correspond to our CH and the CO that was introduced during the synthesis of our mesoporous carbon. And then the peak observed at 693.47 and 466.84 correspond to TIO and a TIOC. And then the presence of this TIOC indicates the success of our mesoporous carbon coated with the titanium dioxide nanocomposite. And the second result is TEM. So TEM was used to investigate the particle size of our samples. So now I have decided to put the mesoporous carbon, as you can see from the figure 7A, which is a mesoporous carbon, figure 7B, which is the mesoporous coated with the titanium dioxide, and the 7C, which is our lead with the mesoporous carbon with the coated to the titanium dioxide. As you can see from the term, the 7A, the particle size was confirmed using the BET, and then also it was also compared with other results, and then we confirmed that this is a mesoporous. In the figure 7B, which is our mesoporous, our main absorbent, we have noted some spherical structures that are in the nano range. And these results were in agreement with the instruments such as the XRD. So as you can see here from the EDX, we decided to put only one spectrum for EDX. EDX is responsible for identifying the elemental composition of our metal loaded on our absorbent. So as you can see from the structure there on the spectrum, the lead, the instrument managed to pick up it managed to pick up the lead. It shows that this mesoporous carbon coated with the titanium was able to remove lead in our wastewater. And the third instrument was the scanning electron microscope. Scanning electron microscope was used to investigate the surface morphology of our samples. So as you can see from here, this the figure 8AC is our mesoporous. We are interested to increase the surface area and also to create the porous on the surface. So the figure 8, we have noted that there is a porosity, and also even the surface is also larger. So these samples, like the mesoporous coated with the titanium nanocomposite and our lead loaded on our mesoporous carbon coated with the titanium dioxide, were also confirmed. The morphology were confirmed using the previous studies. In the batch absorption study, the effect of pH and dosage were studied. So the effect of pH was studied to determine what pH is required to remove lead in wastewater. As we can see from this, that at pH 4 equilibrium was reached. So it was reached at 98%, high removal of 98%. And then pH 4 to 6, it shows that there were more charges in the lead solution to bind to the surface of our nanocomposite. And then from pH 4 to 12, it shows that there was no absorption taking place. And then the effect of pH was also studied to determine how much is required to remove lead in wastewater. And then it was observed that at pH, at dosage 8 milligram was the minimum mass required to remove lead in the wastewater. And then we went further to study the absorption isotherm and then absorption kinetics. So we have used a different calculation to calculate these models. In this case, we're using Lamaya, Frank-Leek, and then a Temkin. So as you can see from these graphs, we have used some of the values such as the correlation coefficient. And then for Lamaya, which is 0.99, Frank-Leek 0.97, Temkin, which is 0.95. So from this data calculated, the absorption for Lamaya was favorable, and of course the data were best fitted for Lamaya model. So absorption kinetics was available in determining the absorption rate to be considered for practical applications. So CO2 first order, CO2 second order, and the intraparticle diffusion model were studied. So we are also using the correlation coefficient that was used to describe the suitability of our model. So the CO2, the absorption feeds the CO2 second order model better compared to CO2 first order and the intraparticle diffusion model. So now here it is where you are testing the effectiveness of our lead loaded on the mesoporous coated with the titanium dioxide nanocomposite. So as you can see here, we are trying to enhance the fingerprint details. So as you can see from figure 12A, it is the figure of the before and after. So before, it was when our spin absorbent was not applied, and after, it was when the spin absorbent was applied. So from the after, it was when this was applied. It shows that this fingerprint were visible. It shows that our our spin absorbent was successful in determining the fingerprint details. So in conclusion, we have concluded that our nanocomposite was fast and efficient for removing 98% of lead in wastewater, and also showed the success in detecting the blood fingerprint. I would like to acknowledge my supervisor, the research group members, the CSIR for organizing this symposium, GST CSIR for funding this project, Department of Chemical Science, and the University of Johannesburg. And then this is the end of the presentation. Thank you.
Thank you very much, Tony, for the great talk.
Okay.
We do have a minute for questions. Does anyone have questions for Widumelo? Widumelo, mine, I think it's a lecture. I need a lecture. Okay, I missed the part of the fingerprinting part. Please just explain to me how exactly does the fingerprint part fit in this project. I understand the first part that you used the non-composite to reduce lead levels in the wastewater. Okay. So I just don't seem to find where the fingerprint part fits. Please explain for me.
Okay, the reason for introducing forensic, the reason for for introducing the forensic part in the wastewater treatment is because most researchers, they are removing pollutant from wastewater. And then what will happen at the end of life, like during disposal, it will cause the secondary pollution. So in this case, we are trying to eliminate that secondary pollution. So instead, we are using the pollutant removed, and then instead we are testing the effectiveness in the forensic application to solve crime. So we are solving crime using our pollutant.
Okay.
Yes.
Okay. Thank you very much.
Okay.
Thank you very much. Let's give her a big round. Thank you. Thank you, Tumi. Our next speaker is Ms. Tina Chunga. She's a CSIR candidate researcher, and her topic that she'll be presenting on today is called Comparison Between Major Chemical Markers of the Cultivated and Wild Harvested Xenophilus aethiopicus African ginger from Mpumalanga, South Africa, using liquid chromatography mass spectrometry. Please share with us your findings. Good luck.
This is back. This is the pointer. Forward. Yeah, that's next.
Good day, everyone. As introduced, my name is Tina Chunga. I am a candidate researcher with an academic background in chemical engineering. Today, I'll be presenting about the comparison between the major chemical markers in cultivated and wild harvested Staphylococcus aethiopicus African ginger from Mpumalanga, South Africa, using liquid chromatography mass spectrometry. I'll be taking you through the background, introduction, aim and objectives, materials and methods, results and discussion, and finally conclusions and recommendations. In 1992, traditional healers in South Africa, known as the Traditional Healers Committee, approached the CSIR in connection with a panel of medicinal plant species that they use in traditional medicines. This led to the signing of the Head of Agreement, Memorandum of Agreement, and Benefit Sharing Agreement. After the signing, the Traditional Health Committee shared their indigenous knowledge with the CSIR pertaining the several plants. One of the plants was African ginger, scientifically known as Staphylococcus aethiopicus. According to the Traditional Healers Committee, the medicinal traditional use of African ginger are in the treatment of allergic diseases like flu, asthma, colds, and sinuses. This collaboration led to the investigation of the traditional uses of African ginger through research and development. In 2014, CSIR conducted a study where they found that African ginger is safe and efficacious against asthma through in vitro and in vivo studies. In vitro studies involve the studies in a test tube or petri dish using cells, tissues, or organs, while in vivo use animals like mouse or sheep. The research also found that the major chemical marker in African ginger is part of the class of sesquiterpenoids. Process development technology was optimized and licensed, and several patents were produced from the studies. However, further development of African ginger through clinical studies are required. Through the knowledge of the traditional healers, it was said that African ginger is mostly used for allergic diseases. According to the World Health Organization, allergies are a major healthcare problem impacting about 40% of people globally. Asthma is one of the most problematic diseases in developing countries, including South Africa. For instance, in 2019, 262 million people suffered from asthma, and of these, 461,000 people died. Asthma is a chronic disease that leads to the narrow of air passages in the lungs due to inflammation and tightening of the muscle around the small airways. Currently, there is no cure for asthma. This leads for the exploration of indigenous knowledge systems in relation to medicinal plant use, such as African ginger, in the treatment of asthma. The picture there below shows African ginger capsules and syrup that were developed by the CSIR as prototypes. So a little bit of an introduction to African ginger. African ginger is an indigenous, wild-growing, flowering plant that grows annually from a stem-like leaf base. Its roots and rhizomes grow at near ground level shortly after the plant has started flowering. The traditional uses of African ginger in a medicinal perspective that were found through literature was in the treatment of coughs, influenza, cold, minor asthma, hysteria, menstrual and stomach pains, sexually transmitted diseases, and malaria. The distribution of African ginger is restricted in South Africa in the Mpumalanga, KwaZulu-Natal, and Limpopo province. However, sadly, these wild-growing African ginger plants have become extinct due to overharvesting. The first picture below is a picture of the African ginger showing the leaves and the purple flower of the African ginger. The second picture, we can see the whole uprooted African ginger plant. And the third picture, we can see the roots, the stem and leaves, and the rhizomes of African ginger. Through chemical analysis research done on the African ginger rhizomes using ultra-performance liquid chromatography, UPLC, it was found that African ginger rhizomes consist mainly of terpenes, alphatic acids, benzonoid, and alphatic aldehydes. The most dominant class of these compounds are the ciscoterpenes. The properties of ciscoterpenes are antimicrobial, antioxidant, cellular repair, anti-inflammatory, and antibacterial. The picture below shows a group of ciscoterpenes that was isolated from African ginger rhizomes. The first one is the sulfanoxylone. The second one is a hydroxylated derivative. The third, fourth, and fifth are the oxidized ciscoterpenoids. Due to overharvesting and thus extinction of African ginger, cultivation sites are required to conserve African ginger. This will be useful in providing a continuous supply of this medicinal plant. Several cultivation sites have been identified in South Africa by the CSIR. The IKS team visited 2 of these sites in Mpumalanga. The first one is from a commercial farmer that grows African ginger in an uncontrolled environment in an open space. And the second one is from a nursery in Sun Park, Kruger National Park, where they grow African ginger in a controlled environment in an enclosed space, and they also use different fertilizers to compare the growth of the African ginger. The determination of this cultivation site has led to the need to conduct chemical fingerprint of the cultivated African ginger and compare it to the wild harvested African ginger. The cultivated African ginger is grown, as we see in the pictures, it's grown and planted, while the wild harvested usually grew automatically, spontaneously in the natural environment. This leads to the aim. The aim of the project was to compare the chemical markers of cultivated African ginger with wild harvested African ginger from Mpumalanga using the LCMS. The objective was to collect the African ginger from the cultivated land in Mpumalanga, to process the African ginger into grounded material, powder, to prepare 3 ethanol extracts, and finally to conduct analytical studies using LCMS and compare it to the reference sample, which is of the wild harvested African ginger. The materials that were used were 100% ethanol, tap water, wild harvested ginger, cultivated ginger, and the equipment were an oven, a hammer mill, Wadman grade 2 filter paper, magnetic stirrer and magnetic stirrer bars, a plastic funnels, glass beakers, and the LCMS equipment machine. The picture below shows the wild harvested ginger that we used as a reference sample. Since African ginger has become extinct, we used the wild harvested ginger that was left from 2014 when CSIR did the study on the chemical marker analysis. This was stored from 2014 in a cold room at 4 degrees Celsius to prevent microbial contamination. And the rhizomes are shown, which were cultivated from the land of the commercial farmer in 2021. The method starts with the pre-treatment of the African ginger. The pre-treatment was conducted firstly by washing the rhizomes of the African ginger, the roots and rhizomes of the African ginger, which was to remove the soil and any other contaminants that may be present. The second step, indicated by B, was to slice the rhizomes to prepare it for the third step, represented by C, the drying of African ginger roots and rhizomes. The drying was done in an oven at 60 degrees Celsius for 3 days. After the drying, the dried material was then milled in a hammer mill with a sieve size of 6 millimeters. This was now ready for extraction. The extraction process begins with the powdered African ginger that we milled. This was done for both cultivated and wild harvested African ginger samples. The first step was the first extraction, where 10 grams of African ginger was extracted using 100 mils of ethanol for an hour. After an hour of extraction, the solid liquid mixture was then filtrated. Then the liquid after filtration is stored into a beaker for further analysis, and the residual unspent African ginger powder is re-extracted for another hour in a similar process. The second filtration takes place, which then the liquid after the filtration is accumulated into the same beaker as before. Then the third extraction takes place, where the same, sorry. Oh, sorry. Okay, so the third extraction happened overnight with the same amount of solvent. Then the third filtration, which accumulated the liquid extract and the residue of the unspent biomass was then discarded. The liquid that is now rich in the bioactive material from the African ginger is then evaporated to remove all the solvent, leaving behind the powdered material, which is a bioactive ingredient from African ginger. This was then sent for analysis using the LCMS. The LCMS machine was used, and the MarkerLinks TM software was used to compare the similarities and differences in the 2 African ginger samples. Both wild harvested and cultivated African ginger samples were sent through the LCMS. These are the results of the chromatogram of the 2 African ginger samples. The first one, A, is from a study that was done in 2014 by Fouché and team from the CSIR. They identified the major chemical compound as this large peak, and they elucidated and isolated it and identified it as siphonochelone, which they then did further studies, and they found that this is the one that is responsible for the treatment of asthma and other allergic diseases. We compared it with the chromatogram that we got from the cultivated African ginger. We also identified a similar large peak, which was also identified as siphonochelone, the major chemical compound. 2 other secondary peaks were identified. In this, the observation was that the major chemical compound that was demonstrated and proven to treat asthma in 2014 from the wild harvested African ginger was also obtained from the cultivated African ginger. So here, the comparison was between the cultivated African ginger chromatogram and the wild harvested African ginger chromatogram, which was recently analyzed from the sample that was stored 7 years ago. Here it is shown that the sample that was stored 7 years ago, after being extracted this year, now shows no presence of the major chemical compound, which was found 7 years ago. It's no longer present now. And then there are other 2 major chemical compounds that were identified as compound 254 and 257. This disappearance of the major chemical compound is due to auto-oxidation of siphonochelone. This implies that the major compound siphonochelone is not stable. As we can see, even in the present sample of the cultivated, we can also see the oxidized derivative because this was analyzed 4 months after it was extracted. This shows that the instability of the major chemical marker, siphonochelone, is fairly slow. The 2 derivatives that were found were not chemically identified. This leads to the conclusion, according to the results that was found, the major chemical marker of the cultivated African ginger extract and that of the wild are the same. However, we also observed auto-oxidation of the compound, which implies instability. The 2 derivatives, even after 7 years, they show that they are stable. So this calls for further research on these 2 derivatives, on investigating their potential to treat human diseases using in vitro and in vivo studies. This leads to the conclusion that cultivated African ginger can be used to further develop traditional medicine through clinical studies and later be registered as a complementary medicine. And the recommendation from this study was that more studies and investigations need to be done on African ginger leaves to also investigate their potential to treat human diseases. Thank you. Any questions?
Thank you very much. Before I give you guys a permission, she's talking about ginger, which has become my friend during the COVID
So the two gingers are from the same family, but different. So the only difference is in the chemical composition. So the chemical fingerprint of the two gingers are different. Therefore, they might have different biological effects in the human body.
But I do hope that that's major chemical because I consume it. One day is sweet, one day is powder.
Yes.
But my worry now is that reduction in the major one. I need to contact you again. Thank you. Do you have any questions for Tina, guys?
Okay. Oh, should I pick? Yes.
Hi, I have just two questions here. First, I would like to understand have you go in details in studying this ginger in terms of treating the virus and treating the bacteria, because these are two different animals which cause diseases. So I want to understand if you did separate studies on both bacteria versus virus. And I want to understand, my question number two is, as currently our problem is COVID-19, how effective is ginger in terms of treating COVID-19?
Okay. Okay, so in the studies done in 2014, they did biological studies on anti-inflammatory, looking at asthma. So it was efficacious, effective through fighting like anti-inflammatory activities. However, they didn't do antiviral studies. And in this study, we were just trying to say, since the wild harvested African ginger is extinct, now can we still do further studies with cultivated? Are these still the same? So this was the current study, but then further studies will take place in terms of antiviral activities and antibacterial activities.
Thank you, Tina. We will take one more question.
No, it's the mic. Oh, okay, we haven't done the initial assessment of the rhizomes. Yeah, however, when we, the main idea when extracting is to remove all the other unwanted compounds, just to have this one isolated major compound that is that is responsible for the bioactivity. So if we might, that might be for further studies to just compare the differences. Yeah, we might do that for further studies. Oh, yes.
Oh. Hi, Tina.
Yes.
Well done on your presentation. You've answered my question through now.
Oh, okay.
Yeah,
okay. Thank you.
Thank you very much, Tina. Those of you who still wish to engage, okay.
Last time.
Okay. Go.
Okay, Tina, thank you for the informative presentation. I just want to know if I'm going to obtain the same results. If, for instance, you mentioned that you dried your ginger at 60 degrees in the oven. So will I get the same results if I dry it in the sun?
Okay, so the process of drying was, the whole process was optimized. So the difference in the temperatures might lead to, because African ginger is very volatile. So when you dry it at higher temperatures, you might lose your volatile substances, which are the major compounds. So you might have different results. You might find that the active ingredient is not there because it's very volatile.
Thank you. Thank you very much. Thank you very much. Thank you. Thank you very much, ladies and gentlemen, for attending this session. Now we've come to the end of this session. We are going to lunch now. But after lunch, please do remember. Okay. After lunch, do remember to join other sessions, and also we've got exhibitions. Do visit those stalls, please. Thank you very much, guys. Have a lovely day. Bye.
I think it's this cable here. Back to the lips now.
Don't take it out without switching off.
Yeah, I'm not taking it out. Just check for me. I just want to.
I will. I'm going to every program.